So before seeing all these concepts, okay, what are the various times and all this, let's see what's the difference between point in time and duration in time. Okay, what is the difference between both these terms? Okay, let's understand these terms first. Okay, let us assume there is a person, say A. Okay, the name of the person is A. Okay, he is planning to going to office. Okay, let us assume he has reached the office, which means he has entered the office at 1 a.m. Okay, at 1 a.m. he has entered the office, and then he worked till 3 a.m. and he left the office at 3 a.m. Okay, he left the office at 3 a.m. Fine. Now, this now when did he arrive to the office? He arrived to the office at 1 a.m. Okay, this 1 a.m. is also called as point in time. Why? Because it is a single point. Okay, 1 a.m. is a single point in time. Now, similarly, when did he leave the office? He left the office at 3 a.m. and this 3 a.m. is also a point in time. Okay. Now, how many hours did he work in the office? He worked in the office for 2 hours, right? This duration of time from 1 a.m. to 3 a.m. is what he worked for. Now, this duration is nothing but 2 hours. Now, this 2 hours is also called as duration in time. Okay, his working time is nothing but duration in time. So, that is the difference between point in time and duration in time. Okay, now let's see these things. Fine. Now we know that initially the program will be completed from source program to machine program, and then it will be placed inside the hard disk. Then it will be moved into the RAM. Then once the process is in RAM, it can be either executed or the IO will be done for the process, or it will be waiting for some event to happen. All these things. Okay, this is what we have seen so far. Now, at some point in time, a process will be moved from hard disk to RAM. Okay, that point in time, I'm not saying duration in time, I'm saying it is point in time. That point in time at which the process is moved from hard disk to RAM is also called as arrival time. Okay, it is also called as arrival time. Arrival time is nothing but it is a point in time it is a time at which a process has arrived to the RAM. Let us assume it is 2 a.m. Okay, at 2 a.m. a program has arrived from hard disk into RAM. That is what we mean by arrival time. Okay, fine. Now once a program has arrived into the RAM, what can happen? This program will be executed for some time by the CPU. Okay, it will be executed for some time by the CPU. Now in case if a higher priority process comes into the RAM, this process will be preempted, which means this process will be stopped for some time, and the high priority process will be continued execution, right? Let us assume P1 is being executed by the CPU, then a high priority process, say P2, came into the RAM, and so we have preempted P1 and we have continued with P2. Okay, fine. And now what P1 is actually doing? It is actually waiting. Okay, it is neither executed by the CPU nor it is undergoing IO. It is actually simply waiting to be executed or to be for IO. Okay, it is waiting for one, either it is waiting for execution or it is waiting for IO. It is not doing anything productive. It is as of now it is actually idle. Okay, this process is idle inside the RAM, which we have already seen before, as it is in ready state or it is waiting or it is actually waiting. Okay, fine. Now the time we have already seen that the time at which, let us assume the process has arrived into the RAM at 1 a.m. Okay, now it has completed its execution, which means the entire process is done at 3 a.m. Okay, now this 1 a.m. is called as the arrival time, which means this is the time at which the process came into the RAM. Okay, and this is the time, the 3 a.m. is also called as completion time, because at this time the process has completed its execution and this process can be removed completely from the RAM. Okay, this is also called as completion time, and completion time is also a point in time. Okay, now this 2 hours, which means the time at which the process came from the time at which the process came into the RAM till the process has completed its execution, this 2 hours is also called as turnaround time. Okay, it is also called as turnaround time. For computing turnaround time, we have a formula. Okay, we have two formulas actually. Completion time minus arrival time. Okay, which means here it is 3 a.m. minus 1 a.m. It is nothing but 2 hours. Okay, the turnaround time is 2 hours. See, turnaround time is the duration in time. That's why the unit is hours and it is not a.m. Whereas completion time is a point in time, arrival time is a point in time. That's why the unit of completion time is a.m. The duration, the unit of arrival time is a.m. But still, the unit of turnaround time, which is 2 hours, the unit is nothing but hours, right? It is not am. Fine. So turnaround time is nothing but the duration of time in which the process is inside the RAM. Okay, the total time at which the process is inside the RAM, it is also called as turnaround time. Fine. Now, what is meant by waiting time? See, in this turnaround time, what are the things which could have happened? For example, there is one possibility is process P1 might have been executed for some time. Then a higher priority process came into the RAM, and so we preempted P1. Then we could have started with P2. Okay. Then once P2 is done, we could have again started with P1. Then let us assume high priority process, say P3 came into the RAM, and once P3 is done, we again continued at P1. Let us assume P1 has completed its execution at 3 a.m. Okay. Now in this thing, what are the things which have happened? P1 is nothing. P1 has executed for this time, and it has waited for this time, which means P1 has waited for this time, and P1 has again executed for this time, and again P1 has waited for this time, and again P1 has executed for this time. Okay. So actually what have happened here is, in this turnaround time can be computed by, turnaround time. There is another formula for turnaround time. Okay, I'm writing in short as TAT. It is turnaround time. It is equal to burst time plus burst time plus IO time burst time plus IO time plus waiting time. See, here we have not here we have not actually included IO. Okay, see, there is a chance that a process might not need IO itself, which means it comes into the RAM, it waits for some time, or it executes and then it completes. Okay, it doesn't need any IO. Okay, which means it doesn't need to read or write into any of the IO devices. That is also still possible for a process, right? There is no compulsion that every process should do IO, right? That is what is happening here. Now let us assume, here we have assumed that our IO time is 0. IO time is also a duration in time, which means the amount of time, let us assume 3 hours or 4 hours is the time spent by this process in performing IO, in which means in reading or writing from some IO devices. Okay, that is what we mean by IO time. So we can say that turnaround time equal to burst time plus IO time plus waiting time. Okay, this is one formula. Also, this formula is also correct. Okay, turnaround time equal to completion time minus arrival time. Fine. Now after turnaround time, we have something called as waiting time. Okay, now what is the waiting time of P1 here? P1 has waited for this duration, as well as P1 has waited for this duration. Okay, these two times. Okay, how will you compute the duration here? This minus this. For example, if this is 2 a.m. and if this is 1:15 a.m., 2 a.m. minus 1:15 a.m. is nothing but 45 minutes. Okay, here it is 45 minutes. Similarly, we can also compute it here. And if you add these two duration of time, we can compute the waiting time of process P1. Okay. Fine. See, in case if you didn't understand this very clearly, we are going to see this is not actually a problem. Okay. This is just an example to explain the concepts. We will see a complete problem. You will be able to understand all these things very clearly. Okay. Fine. So waiting time is nothing but the time spent by a process in the RAM without actually executing as well as not performing IO. It is simply waiting inside the RAM to be picked by the CPU for execution in the future. Okay, that is just, it is ready. Actually, the process is ready to be either executed or performing IO, but due to lack of resources it is actually waiting. Okay, that's the amount of time which is spent by a process in waiting. We say that as waiting time. Okay, and waiting time is the duration in time. Okay, waiting time is the duration in time. Fine. Now we have something called as the response time. Response time we'll see a bit later. Okay, even if I say this, you will not be able to understand. We'll see it a bit later. Now we have something called as IO time. You already know it, right? The amount of time which is spent by a process in performing IO after it has arrived to the RAM until its completion is called as IO time. Okay. For example, if process P1 has arrived to the RAM at 1 a.m. and it has completed its execution at 3 a.m. and in case if it has spent from 2 a.m. to 2:15 a.m. in performing IO, then IO time is nothing but 15 minutes. Okay. IO time is also a duration in time. Okay. Fine. These are the various times we have. We didn't see only one thing, and that is response time. Okay. We will see it a bit later. Even if I tell it now, you might not be able to understand it very clearly. Okay. After seeing an example, you will be able to understand response time. Okay. Fine.